What started as a scrappy gaming graphics company in the 1990s is now the single most powerful player in artificial intelligence. NVIDIA went from rendering 3D pixels in games like Quake and Tomb Raider to powering ChatGPT, Tesla's self-driving cars, and the world's fastest supercomputers. But here's the question. How did a graphics card company become the king of AI? Why did GPUs, once seen as just for gaming, completely crush CPUs in the AI arms race? And more importantly, can anyone stop NVIDIA? Stick around because this story isn't just about technology. It's about money, power, and the future of intelligence itself.
To understand NVIDIA's rise, we have to start with the fundamental battle: CPU versus GPU. CPUs, central processing units, are the brains of your computer. They're fast, precise, and designed for sequential tasks, perfect for running your operating system, browsing the web, or editing a spreadsheet. But GPUs, they're built differently. Instead of a few powerful cores, they have thousands of smaller cores working in parallel. Think of CPUs as a world-class sprinter, fast on a straight track. GPUs, on the other hand, are like an army of marathon runners, all moving together. This difference matters because AI isn't about single tasks. Training a large language model like ChatGPT requires performing billions of tiny calculations simultaneously. CPUs choke on that scale. GPUs thrive on it. That's the key. GPUs weren't just better for graphics. They were secretly the perfect tool for AI.
But having powerful hardware wasn't enough. GPUs were great at parallel tasks, but developers needed a way to actually use them for more than just graphics. That's where CUDA came in. In 2006, NVIDIA launched a new programming model, CUDA, that let researchers tap directly into the GPU's power for general computing.
A visual history of CUDA, from graphics to AI revolution.
In the early 2000s, a revolution was brewing in the world of computer graphics. Researchers saw the raw, parallel power of the GPU and asked a daring question: what if we could use this for more than just games? 2006, the official birth. NVIDIA launched CUDA alongside the GeForce 8800 GTX GPU, introducing the first hardware and software architecture designed for general-purpose parallel computing. This marked the beginning of accessible, large-scale GPU computing. 2007, reaching developers. NVIDIA released the CUDA Software Development Kit, SDK, for Windows and Linux, empowering developers to create applications that harnessed GPU power. This move expanded CUDA's reach and fueled early innovation. 2008, growing up and going pro. CUDA 2.0 brought support for macOS and, critically, double precision calculations. This update made CUDA indispensable for scientific and high-performance computing, where accuracy and cross-platform compatibility are essential. 2012, the AI Big Bang. The AlexNet model, trained on CUDA-powered GPUs, decisively won the ImageNet competition. This event validated GPU-accelerated deep learning, ignited the AI boom, and cemented CUDA's role as a key enabler of modern artificial intelligence. 2015, the strategic pivot. NVIDIA released CUDNN, a GPU-accelerated library for deep neural networks. This library became the core optimization engine for TensorFlow, PyTorch, and other major AI frameworks, accelerating NVIDIA's focus on AI and machine learning. Present: ecosystem dominance. Today, CUDA's extensive adoption across AI and high-performance computing has created a powerful software ecosystem. This widespread reliance results in significant lock-in, making CUDA the foundational platform for parallel computing and AI development worldwide. And here's where the story gets even bigger: the money.
Back in 2016, NVIDIA was worth just $16 billion, a respectable gaming company. By 2020, it passed $300 billion, riding the wave of data science and early AI hype. But today, NVIDIA's market cap has exploded past $4 trillion, making it not just one of the most valuable companies in tech, but in all of human history.
So, how did this transformation happen? Simple. Demand.
NVIDIA's flagship H100 GPU, the chip behind ChatGPT, Tesla's self-driving cars, and countless AI labs, sells for over $30,000 a piece. Entire AI startups are burning through millions of dollars just to secure a single batch. To put that in perspective, that's more expensive than a new car per chip.
And the numbers keep climbing. In its fiscal year 2024, NVIDIA brought in $60.9 billion in revenue, but the real headline is the data center business, where AI lives. Sales there grew over 140% year over year, fueled almost entirely by the hunger for AI compute power.
By some estimates, NVIDIA now controls over 80% of the global AI chip market. That's not just dominance, that's near monopoly territory.
Think about it. Every time an AI model trains, every time ChatGPT answers a question, every time a company launches the next big AI breakthrough, chances are NVIDIA is getting paid.
But can anyone catch NVIDIA?
AMD is NVIDIA's most direct rival in the GPU space. Its Instinct MI300 series, particularly the MI300X, is a powerful competitor to the NVIDIA H100. Key advantage? The MI300X offers a massive memory edge, up to 192 gigabytes of HBM3, more than double the H100's 80 gigabytes. Perfect for training the world's largest language models. The challenge? But software is AMD's Achilles heel. Its ROCm ecosystem is improving, yet still lags behind NVIDIA's CUDA, which dominates AI development worldwide.
Intel, the old chip-making giant, is back in the fight with its Gaudi series accelerators. The latest, Gaudi 3, is built for efficiency and cost-effectiveness. Key advantage? Intel uses standard Ethernet, not NVIDIA's costly InfiniBand. For data centers, that's a game changer, lowering networking costs while still delivering strong AI performance. The challenge? But Intel is still playing catch-up. Its ecosystem and developer support simply aren't at NVIDIA's level yet.
From rivals like AMD and Intel to disruptors like Google and Cerebras, the race is on. But for now, NVIDIA's ecosystem keeps it firmly in the lead. The real question is, how long can that dominance last? If you enjoyed this deep dive into tech dominance, make sure to subscribe to Origin Lens for more stories that uncover the hidden origins shaping our world.